All right, so for RC4 or our objective 4, okay, this is when we get into quadratic functions and equations, writing and solving the equation. So our quadratic function or equation, this is when we have our parabola. So these are some key facts that we need to be able to know how to use. The first thing is standard form. This, I believe, is on the formula chart. And also, we just need to remember that it needs to, when solving, we want this equal to 0, okay? And we want a squared plus b squared plus bx plus c. We want that so that we can use it for quadratic formula. Sorry, I'm trying to fix that. In case whenever you're trying to solve when you have square roots. The other part is how the parabola looks when a is positive. This a, we're talking about this lead term, versus when it's negative. Positive opens up, negative opens down, and then understanding where the vertex is or what that vertex represents. So this point here in this example is a minimum. That's the vertex. Here, this is a maximum. When I have an h and a k that can represent the vertex, that can be used for vertex form. So you could probably add this to your notes, your vertex form, but this is on the formula chart as well. Oops, let me fix that. Your vertex form is whenever we have y equals a parentheses x minus h plus parentheses square plus k. That's okay, sorry. That looks bad. Let me fix that then. Oops. And just get rid of that line. Okay, and we want that because we want inside the parentheses the h and then outside is the k, and that helps us get into vertex form or understanding how to read the vertex form if they give you that as an answer choice. So our examples here is whenever I see the word, not really the word, it's the expression x squared, okay, we remember to set equal to 0, put into the graphing calculator and to look at the graph. So in this example, if I have f of x equals x squared plus 2x, okay, if I have it equal to 0, that's how I would solve it. But to put in the graphing calculator, basically my f of x is my y. So I'm just going straight to typing this in the calculator. So let me just kind of get that up there. And then we want to graph it in the calculator so that we can look at some key components. Let me clear this out. Clear that out. So we have, make sure that's positive. We have x squared plus 2x minus 3. We're going to graph that. Okay. From there, I'm going to put, if you notice, y equals 0 here. Because to get solutions, to get actual zeros, intersections, you need 2 equations always in. And that will help me when I need to find my zeros. Here, I just want to find my vertex. And some of the keystrokes that help you do that is I can physically see this is a minimum. So if I do second trace and pick 3, which is a minimum, the cursor wants to be on the left. This is left bound right here. Right now the cursor is on the right side of the curve, so I need to get it on the left side of the curve, which is right there. Hit enter, then move it to the right side of the curve. There we go. Enter and enter one more time. And then you can physically, I know this is negative 0.999, but I can physically see that that's at a -1, -4. That's my intersection point. I mean, that's my vertex point. So my vertex is here at negative, let me put that in right, sorry, -1, -4. I know this had a minimum. That minimum value is that x, the y coordinate value, so that's -4. And so -1, I'm just sketching this graph. And so now to deal with my axis of symmetry, my axis of symmetry goes through that vertex, and it's a vertical line, all right? So that correlates with the x coordinate. So this is x equals -1. And then I can sketch my graph looking for my intercepts. This is when I was talking about wanting the y equals to be 0. on the second equation, because now I can find these intersection points by doing second trace, hit 5 for intersect, and just hit enter 3 times. There's one of my intersections. I can physically see these. So if you're lucky enough that the graph is exact and you can physically see those points, then you can just go from there. So one of the zeros or intercepts or the roots is at a -3. So hold on, let me fix this. So sometimes we use the bracket notation, -3, comma 1. So I got a point right there, point right there. Our parabola is going through those points, so I'm just kind of sketching this. It needs to go through. Then my vertex is where it starts to turn, and then it comes back up. Okay. So as for my y-intercept, I should be able to physically see it. If not, like if I don't see it, it's where the x is 0. So if I go second graph to the table, there it is. It's at a -3. So we got that point. The y-intercept here is 0, -3. Set this point. Okay. And then here, sorry, are my solutions. It's another way, or you can say your zeros. As for my range correlates with my vertex. Since this graph is opening up and it has a minimum, then my range is greater than or equal to the -4. Our domain is all real numbers. Anytime I see double arrows pointing up, we got all real numbers. Okay, so it's just kind of going over the parts, making sure you can identify those using your graphing calculator to help you problem solve. Now, this example here is writing the equation in standard form. So these were the steps we had to memorize and when we end the unit, where it said the first thing we do is we have to expand this binomial. Okay, so the -2 is going to stay in front, but we got, this means 2 factors of x plus 2. So we're going to write x plus 2 twice, and then keep the -12. Now after we expand, we have to use the FOIL method. So -2 is still in front, and that is first times first, so that's x squared. Outer, that's 2x. Inner, that's another 2x. And then last, that's 4. And then we have outside, parentheses -12. Now, in our FOIL method here, you want to combine these like terms before you do the third step, which is distribute. So our negative, sorry, that's supposed to be in black, 2 is outside the parentheses, and we have x squared plus 4x plus 4, and then -12. All right, so now the third step is to distribute. Okay, so when I distribute, this is going to give me a -2x squared minus 8x minus 8, and then that -12. And so the last thing we have to do is combine these like terms, these constants. So our y equals a -2x squared minus 8x minus 20. That's the standard form. Okay, so this is the type of problem I said will most likely be open-ended. At least it has been in the past in some of the sample style questions. So make sure we can, because what they're going to ask you to identify is the coefficients, the A, oops, hold up, sorry, the A, the B, and the C. Okay. All right, or just type it out. Actually, that could be that's the math response type, instead of a drag and drop. And then our last little example is being able to find these parts off of the graph. So linear factor, this is basically asking you to do this in factor form. And factor form is always tied to parentheses, okay? And usually it's x minus some type of number, or it could be x plus some type of number. But that number is the y-intercept, but the opposite. So like, this is kind of what we did on the very beginning of our packet, our booklet here. I can physically see the zeros right here. This lets me know x equals 3, no, -3, sorry, let me fix that. -3, and here is the other zero or solution, x equals -1. So when I put this in factor form, I'm doing the opposite. When it's in parentheses, when I'm putting it back into parentheses, basically, that's what I'm saying. We have to do the opposite. When we take it out of the parentheses, we do the opposite. So our factor form here is x plus 3 and x plus 1. And it would be equal to 0. Okay. Now, to go into standard form, because we have our factors here, we're now going to have to use FOIL. We want to use FOIL of our factor forms. And so we're going to distribute here the first terms together. So that is x squared. Outer terms, that is just an x. Inner terms, that's 3x. Last terms, that's 3. And we want to simplify this. So now we're just combining these like terms here. So standard form here will be y equals x squared plus 4x plus 3. Okay. So just make sure we can read the key components. Another key component that wasn't asked on here, but like your axis of symmetry, like you might have, make sure you're writing that as x equals -2. Maybe your vertex, obviously, or your y-intercept. Okay. But that pretty much covers up quadratics. Just because methods of solving that is in a previous objective. So we kind of already talked about that. All right, so thanks for getting this updated. And we'll go over the last little thing. Make sure you're doing your quizzes. All right.